So this is a bit of a reprise with some updates on what we can do if we go to a landing site that has been affected by the ray from Tycho that crosses the poles. So if you can go to the next slide, please. Shortly before the abstract deadline for this meeting, Ed Rivera Valentin sent me their abstract, and we started talking about all of the cool new mini-RF radar, incidence-corrected radar data of this ray. And so Ed has a talk later this afternoon, but I was totally inspired by this radar data and also by the new Lola data from Mike Barker. So they are both co-authors on this work, but it reminded me about that fuzzy time in, I think, May 2020 when we had the first LSSW abstract. And I got very enthusiastic about looking at this Tycho ray, so I decided to dig into it a little bit further. And I want to note, too, that this radar data is very cool, and Caleb Fassett and Ed are underselling how cool it is. So, all right, next slide. So this is the Lola reflectance data. Actually, I should note that Paul Lucy sent me better, new and improved Lola reflectance data. I did not have time to incorporate that here. So this is the old bad Lola data, but you can still see the beautiful ray from Tycho that crosses the South Pole. Now that we have the 13 landing regions, can see that it actually crosses 2 and maybe 3 of those landing regions. So interesting science opportunities there. Next slide. We did visit material affected by Tycho. Well, I should say not we, but Jack Schmidt on the line still, I believe, did, and collected material that had been disturbed by Tycho secondaries. You can see the ray that crosses the Apollo 17 landing site really is much more it's much harder to trace all the way to the site. You can really follow it more through secondary craters in that region. This is the same Lola reflection. Also, this site is about 2,200 kilometers from Tycho, whereas the polar regions are about 1,300 kilometers from Tycho. So you get a probably better look at that ray. Next slide, please. Well, there's two things that I'm really interested in that I think this Tycho ray could help us with. One is understanding space weathering. The poles in general are just really interesting for space weathering. There are observations from reflectance and solar wind models and things that show you that as you get towards the poles, the solar wind flux falls off with the cosine of latitude. So the poles are really a good area to understand the relative effects of what's going on with micrometeoroid impacts and the solar wind in terms of causing the reflectance variations that we see with space weathering. And so really any sample from this region is going to be really interesting for space weathering, but in particular because we have that opportunity of material disturbed by the Tycho event at the Apollo 17 landing site. That's the Highlands material in the Light Massif. And now at the other extreme of space weathering at one of the Artemis sites, we could have a really cool direct comparison of material exposed at the same time and in very different environments. Next slide, please. Also, just a really interesting question is how material is transported in rays and by distal mixing in general. So we've recently had some really cool work showing just how distally material can be transported by impact events, including potential antipodal melt deposits to Tycho, and new work showing the way material is transported within rays and then in these distal effects of new impact craters. So looking at some of these mixing models, I think if you go to the next slide, um, there are the Oberbeck et al. 1975 looking at the fraction of material that is transported. So if you are at a distance from an impact crater, what fraction will you have of material from that crater versus local material that has been stirred up by the impact event? So Noah Petro and Peters, they had some modifications to this. I took a quick look at how that would affect the Artemis sites from Tycho, and Tycho would have contributed, according to these models, around 5% to the upper meter-ish or so of the surface in this area. So that's probably, 5 plus 10 minus 5. I don't know. There's a lot of error or uncertainty, I should say, on that number. So great opportunity to test that. Next slide, please. So this is the Mini-RF incidence corrected radar data that you'll see from Ed later today. And this is showing the Hayworth site. So this is why I love this radar data so much. You can see the left half of this site has really been affected by this ray. And now you can actually pick out which secondaries or which craters here are secondary craters due to these, I guess you're not seeing my mouse pointing at them, but due to the different, tails of ejecta leading away from these craters. Next slide, please. If you add in a map of permanently shadowed regions, this actually shows that some of these Tycho secondaries are in fact permanently shadowed. Next slide. Looking at, now this is the hillshade from Mike Barker's Lola product. You can see blue here is still the PSRs of this site. I've added in some constraints that I sort of made up because the site, these regions are so large, but green is showing low slopes. I think I put this at less than 5 degrees in the area, and yellow is areas of high illumination that Erwan was just showing. Here, this was the average over 18 and a half years. So this was, I think, over 45% illumination shown in yellow. And so I was trying to constrain myself to looking at areas where, okay, great, we have this Tycho ray, we have PSRs in Tycho secondaries, can we actually get at any of this material? And if you find where those two, low slopes, high illumination overlap, you can see there are areas that would provide you access to Tycho secondaries. Next slide, please. Zooming in a bit here, just showing that in more detail with a 4-kilometer scale bar for reference. I should note too that you can see, once you know they're there from this great radar data, you can see the ejected deposits of some of these secondary craters in LROC WAC data that's been corrected to look for albedo in these kind of challenging polar regions. I didn't include that here because I couldn't bear to show how it's not pretty overall at the poles, but you can still see it. All right, next slide. Unfortunately, in this filtered product from Caleb, the connecting ridge and connecting ridge extension sites are basically in a gap of coverage. And so there's not a ton of coverage from the Mini-RF data here. But you can basically trace the ray above and below these sites. If you go to the next slide, please. And once you've kind of done that, you can start to pick out where the secondary craters from Tycho are. And Yes, I forgot I wouldn't be able to have my mouse showing you things here, but I see a mouse. If you move it to the right, there's basically a line of secondary craters that you can trace through this ray, and they're the kind of more distinct clusters. Yes, there, and then kind of diagonally line up above those. So next slide, please. Thank you for the mouse movements, whoever is doing that. This is showing those kind of constraints on top of here again. And you can see why people like the connecting ridge site so much, those broad areas of high illumination that overlap with areas of low slope. Some of these Tycho secondaries are, again, indeed in permanent shadow. There's also a ray from Jackson that may go through here, so it's much less distinct. Glancing through the radar data briefly, it is much harder to pick out any distinct craters that are related to Jackson.
1 minute.
Thanks. Next slide. So this is my main conclusion here. On top of all the other really cool science that everyone has been talking about, yesterday, today, and we'll continue to talk about. These different sites offer you the benefit of a direct comparison of weathering of highland material exposed at the same time, but in different space weathering environments, provides an opportunity to confirm the age of Tycho that is known only from cosmic ray exposure ages of material disturbed at Apollo 17, and to look at testing models of ballistic sedimentation. Plus, you can make observations of PSRs that are within Tycho secondaries, and so these are of known age and potentially constraining the age of any volatile materials within those craters. And with 1 second, I will stop. Thanks.